Welcome back, Raytans. In this short video, I'll be doing the calculation on the relative atomic mass of the isotopes. So I'll zoom into this one. Natural chlorine consists of chlorine 35 and chlorine 37. So here we are given two isotopes, which is chlorine 35 and chlorine 37. They said write down the SP notation. Okay, I'm not going to do the SP notations. I've done those ones. So I want to zoom into this one, which is the relative atomic mass. The relative atomic mass of chlorine is 35,5. Calculate the percentage of chlorine 35 in the natural chlorine. So this is the calculation that we'll be doing. Is 3 marks. So we have two isotopes here. We have chlorine 35 and we have chlorine 37. Okay, so my x's represents the chlorines. Okay, let me just take off the x. Let me put on the chlorines so that I'm not confused. So we have chlorine 35 and chlorine 37. So there's a formula that we use to calculate the relative atomic mass. The formula says the relative atomic mass is equals to the mass number of the first isotope, which is 35. Then we multiplied by the percentage abundance of the first isotope, plus the mass of the second isotope, which is 37. We multiply that by the percentage abundance of the second isotope. Then we divide everything by 100%. This is the formula that we are going to use to calculate the relative atomic, the percentage abundance of the chlorine 35. Okay, now let's substitute. The relative atomic mass is given to be 35,5. So they gave us the relative atomic mass. Here is it. They said it's 35,5. So we don't know the percentage abundance of each. So in this case, let me say the percentage abundance of the first one is X. The percentage abundance of the second one is Y. So let me make this one X and that one Y because of they are both unknown. So let me create an equation here and say the percentage abundance of the first plus the percentage abundance of the second is equals to 100% because they are both unknown. So let's take Y as the subject of the formula. So I'm going to take X now to the other side. So that means the value of Y becomes 100 minus X. So this is now the value of Y. So let me substitute here. Remember, the first one is X. So it's like we have 35 multiplied by X plus the second one is 37. So I have 37 multiplied by Y. Now what is Y? We said Y is 100 minus X. So the first one was X, the second one was Y. So we don't know what is X, but we do know what is Y. Y is 100 minus X. We divide everything here by 100%. So this 35,5 is over 1. So here that means we can cross multiply. 35,5 multiplied by 100. That will give you 3,550. So we have to multiply everything now in the numerator. 35 times X, that is 35X plus 37 multiplied by 100, that is going to be 3,700. 37 multiplied by negative X, that's going to be negative 37X. So we can see that this one and this one are your like terms. This one and this one are your like terms. So let me take now the 3,700 to the left. So I have 3,550 minus 3,700. Then on the right, I have 35x minus 37x. So let's add now these two like terms, 3,550 minus 37. Let's do the calculation. 3,550 minus 3,700. So the answer is negative 150. So I have negative 150. 35x minus 37x, that one is easy, is negative 2x. So I can divide here by negative 2, I can divide there by negative 2. Then I get x to be equals to 150 divided by 2, that's going to be 75. So x is 75. So that means it is 75%. So we do know the percentage abundance of the first atom, which is chlorine 35. Chlorine 35 is 75% because of we know the value of x. Let's find y just for fun. So we have 100 minus 75. We do know the value of x is 75. That means y will be 25%. Yeah, so the percentage abundance of y will be 25%. Yeah, we are done with this question. Let's do now the second question, which is similar to this one, but now this one has 3 isotopes. Now let's look at this one. Here we are given the element X. They said the element X has 3 isotopes, X15, X17, X19, of which X15 has double the percentage abundance of X19. So the relative atomic mass of X is 16,75. Determine the percentage abundance of each isotope. So here we have 3 isotopes. Let's draw these isotopes. We have X15, we have X17, we have X19. So these are the molar mass of these. Remember, isotopes are elements with the same atomic number but different mass number. So we don't know the percentage of X. I'm going to call it X15 is X, X17 I will call it Y, X19 I will call it Z. So we don't know the percentage abundance of, okay, let me use the other variables just to make, because I have X here, I don't want to have X again. So I'll call this one A, I'll call this one B, I'll call that one C. So we don't know the percentage abundance of each. That's what we have to calculate. But we do know that the percentage abundance of X15 is double the percentage abundance of X19. In other words, this one, which is X15, is double the X19. In other words, A is equals to 2C. So we do know that the X15 is double the abundance of X19. If X19 is C, that means X15 should be 2C, is double the percentage of X19. Then they said the relative atomic mass is 16,75. Let's create the formula here. The relative atomic mass is equal to, the first one, the mass number is 15, the abundance now is 2C, plus the second one, the mass number is 17, the percentage abundance is B. The third one, the mass number is 19, the percentage abundance is C. We divide everything by 100%. Yeah, so this is the formula that we are going to use. But we have to create now the formula for the unknowns, because we can't work with 3 unknown variables. So I'm going to create a formula here for all these 3. I'm going to say the first one, which is 2C plus B plus C. So I'm going to say 2C plus B plus C is equals to 100%. Is equal, because we know the total of all these abundance should be 100%. Okay, so let's make now the subject of the formula. Let's take, for example, we can take B, because of we have now B and C. Let's first add. This is 2C plus 1C. 2C plus 1C will give us 3C plus B will be equals to 100. So let's take B, the subject of the formula. So B will be equals to 100 minus 3C. So we do know the value of B is 100 minus 3C. Now let's go and substitute. They told us that the relative atomic mass, let's go back, they said 16, yeah, it was 16,75. Yeah, the relative atomic mass is 16,75, so let's substitute that one. So the relative atomic mass is 16,75 equals to, Now we have to substitute, multiply 15 times 2c, that will be 30c, plus 17 times b, so we're going to say plus 17. Remember, we do know what is b. b is 100 minus 3c. 100 minus 3c plus 19 times c, that will be 19c. We have to divide everything by 100%. Now we can cross multiply here because of this 16,75 is over 1 multiplied by 100. I think that will be 1,675 equals to. Okay, let's calculate this one. 30c plus 100 times 17. That's 1,700. 17 times negative 3. 17 times negative 3. I think that is 51. Yeah, it's 51. So 17 times negative 3 is negative 51c plus 19c. So we have now like terms, this one and this one and that one. These are your like terms. This one and that one, those are your like terms. So let's take the like terms and group them together. So I'm going to leave the c's to the right and take the constants to the left. 1,710. 1,675, I'm going to minus this 1,700 equals to, here I have 30c minus 15c plus 19c. So I have to add all of these now and subtract those ones. Let's start with the one on the left. 1,675 minus 1,700. So the answer for the left equation is negative 25. So this one is negative 25. Let's do the one on the right. We have 30 minus 15 plus 19. So the one on the right is 34. 34c. So this one is 34c. So we want c, so let's divide by 34. We divide the other side by 34. Let me quickly check something. Oh, okay, you can see the mistake here. This is not supposed to be 15, it's supposed to be 51, because if I can see, we cannot have a negative value there. I made a mistake here. It's not 15, it's 51. I don't know where I got the 15. Okay, let me quickly correct this one. Yeah, it's not 15, it's 51. Yeah, let me say we took the 1,675, we take the 17, 1,700 to the left is equals to 30c minus, it's 51, it's not 15. Yeah, so let us now add all of this and subtract. We said on the left we have negative 25, so we need now to add this one. I don't know where I got the 15 from. So let's quickly redo this calculation. So we have 30 minus 51 plus 19. Yeah, we're supposed to have a negative value. Yes, that's negative 2c. So we are looking for c now. So we're going to divide by negative 2, divide by negative 2. So that means c is equals to 25 divided by 2. That's 12.5. Yeah, so remember it's 12.5%. So that is the percentage abundance of C. It's 12.5%. Remember, we are looking for A, we are looking for B, we are looking for C. So we know the percentage abundance for C is 12.5%. Now, we need now to find the percentage abundance of B. The percentage abundance of B, we have to substitute now this 3 by this C by 12.5. So the value for B will be 100 minus 3 multiplied by 12.5. So the percentage abundance of B will be 62.5. So this one is 62.5%. Remember the A, they said now A is 2 times C. That means A is 12.5 times 2. That is going to give you that 25%. So yeah, these are the abundance of each element for these three isotopes. And when you add all of these together, if you add all of them together, they're supposed to give you 100%. 25 plus the 2.5 plus 12.5 is supposed to give you 100%. Yeah, this is how you calculate the abundance, isotope abundance of all of these elements.